Hey, this is Gary, and welcome back to my channel for creating a 2D framework off of LibGdx. Today we're going to cover more of the background images, and then we'll get into kind of layering our sprites on the screen. So let's start by our background. This is our background. It's a basic chessboard, white and black, alternating squares. And this is 920 by 920. So the actual board is 90 by 90. And so what we want is to render this to the screen behind all of our chips. And when it renders, we don't want to test collisions against it because it's just a background image. And so what we're going to do is we're going to create a background object to kind of handle all of our background elements. So we're going to create a new package called background. And what we're going to do, just like our other classes that we've done in our framework, we're going to start with a interface, a background. And this background is going to extend updatable. We're going to have a method for adding animations. So just like our sprites, we're going to have animations in here for all of our images. Give us some consistency. And we'll also need our draw method so that we can render the image upon the screen. And we'll have a set screen origin, and this is used for telling us where the background needs to be adjusted so that it always displays correctly on our screen. And then we need to set the screen size so that our background is appropriately displaying on the screen. Okay, so now we have our background interface. And for now, we're just going to start with a fixed background. And so the fixed background is basically going to render the image in the same location, no matter which way the screen moves, or if the screen doesn't move, it always renders the exact same image. So that, like in our, so as in our chessboard, it will always render the full chessboard onto the screen and not any part of it, so it won't move off of the screen. So if you had a character moving around, it would not move. And we're going to call this fixed background. Right here is our fixed background. So we're going to have an animation that will be rendered to the screen. And this can be any type of animation, whether it's just static or it loops or any other type of animation that we created in previous videos. And then we'll have a flag on whether or not we want to stretch the image of the animation based off of the screen size. And then we have size X and Y. And so this is going to be the size of our animation that we want it to be, whether it is stretched or not stretched. Then we keep track of the height and width of the screen. And then we also have an origin of X and Y. So that's the viewport origin. And so that way our fixed background will be basically fixed and doesn't move if the screen or that viewport moves. So our constructor will take an animation and whether or not we want to stretch it. And so we set everything appropriately. The add animation basically just overrides the animation and then replaces it. And so we reset our size X and Y. I'm going to come back to the draw in just a moment. This sets our screen origin, X and Y location. This sets our screen size. So you pass in the width and the height. And we set the width and height equal to that. And that is for the background's width and height will match the width and height of the screen. And if it's stretched, then it's going to take the animation and set its size to the width and height. And the X and Y will also be set to that same height. Our update method, we'll just call the animations update method. Now back here in our draw method, what we're going to do is we're going to start with the origin of X and Y for our Y and X loops here. And if our Y is less than the origin Y plus the height, which means our image is smaller, it will add the size to it and draw at the next location. So it'll tile it. And so if our animation is stretched, it won't be less than our origin plus our height. They'll be equal. So it'll only render once. So we'll come down into our video tutorial and we'll make a new package. And we'll just call that checkerboard. Call it checkerboard. And then we'll create a new game screen, which will be our checkerboard screen. And it's just going to extend our simple screen. And we're going to add our background here. It's called BG. It's going to be a new fixed background. And we're going to add a static animation. And we're going to get our texture. And what I'm going to do is I'm going to start with that bad logic JPG. And we're going to not have it stretch. So back in our base screen, we're going to add our background object to the base screen. So in our render method, we move the render child around a little bit. So when we do our batch begin, we update our updatables. And then our background, if it's not null, we're going to set its screen origin. We're going to call update, and then we're going to call the draw method. And then we're going to render the child, and then the batch will end. Then our setup screen will, if the background is set, it will set the screen size and the screen origin. And then we change the set background color to set background, which will take our new background object and set it in our screen. And then back in our checkerboard screen, we're going to set the background, create a screen based off of our new checkerboard screen. Whoops. There it is, checkerboard screen. And we'll set our screen size to 900 by 900, and then we'll render that out. And you can see it is an image is smaller than our screen size, and so it tiles it. And we'll go back into our checkerboard screen, and now we'll change that to true, so that'll be stretched. And then we'll run that. And now the image is now stretched. And since our checkerboard is 920 by 920, we'll set. And then here we'll change to be our board. And then we have our checkerboard. And it's fixed upon the screen. Now we're going to get into layers, but first let's start by making our checker pieces. So we'll need to create not a chip, but a checker. Yeah, I like the name of chip better. Our chip is just going to extend actor. And then we got our chip with our movement, move motion, and still motion. And our build chip will just take two textures. And what we'll need is a still motion. And it'll just be a single motion. And it will have a new static animation. And then we'll just pass in our still texture. Then we'll need an animation for our movement. And we'll just do a loop animation. And let's say frame duration, let's just start out with something small. And we'll need to get a texture region. Move texture, and our chips are 100 by 100. And we just need the first element of that array. And our movement, and it's going to be same thing, a single animation, but it's just that loop. Now, what we need is how are we going to move our chips? And what we want to do is we want to be able to click on the chip and drag it to where we want it to go. So for this, we're going to need a new movement. And we're going to create the movement. We're going to call it mouse drag movement. And so what this movement's going to do is allow us to select the chip and then basically drag it around the screen. All right, here is the basis for our mouse drag movement. And we're going to have a button, mouse button, that you would click to activate it. And if it's active, then it would be able to move it. And if it's not active, we can't move it. And button activated is for the situation where we want to be able to click to activate it and then just drag it without holding the mouse button. And if button activated is false, then you have to click and hold it and drag it across the screen. The X and Y offset is where we click in relationship to the 0, 0 point of the image of the object that we're selecting. And we have another constructor, and this is for setting the button activated based off of mouse button ID. And we have a collision that if we hit a collision, we just revert our movement. The X and Y update, we will revert that back. In our update method, now we need to check to see if the mouse is actually over this particular actor. And so we need to check to see if he's over. And in sprite update, we need to do contains the X and Y. Now we also need to add that contains method to our sprite update. Here in our sprite update, we're adding our method contains XY, and then we'll have to update our sprite, my actor, and our decor will need to be updated. Here in our sprite, we add a contains method, and that's going to go to the bounding box, see if it contains X and Y. Here in our bounding box, we added the contains XY, and we do a check X and check Y. Those are down here. These are similar to the other ones, except it's just checking the X and the Y. So we're checking to see if the X passed in, if it's less than or equal to the other X, the one passed in, and that is less than or equal to the X plus the width, and then it's within bounds. And the Y is similar except on the Y axis. So in our update, what we'll do is once we over the actor, we're going to check to see if the button was just pressed. Then we'll get the X and Y offset based off of the sprite's location and the screen input. And then if the button is an activation one, we'll set it to be active or inactive depending on its current state. And if it's button activated, we will set the active or deactive state based off of whether they clicked it or they clicked it a second time. And if it's not button activated, then just holding the mouse button will cause it to move. And then after that activate is set, then we check to see if we are active. If we're active, we get the screen input. And then we set the X update and Y update based off of what the current location of the actor is. And then we set the actor's location to the new location based off of where the current mouse is at. And if it's not active, we reset our X and Y update to 0 so that if any collision happens, the sprite will not move. Okay, now we're back in our checkerboard and we'll create our new mouse drag movement. And we'll set that to our left mouse button. And then we'll get our chip. We'll build it. We'll pass in the red chip for our still texture and the red chip move for our move texture. And I'm going to flip these around. And then we're going to set the chip's location. And we'll just put it at 100, 100. And then we'll give it a test run. Here is our chip, our actor. And if I click elsewhere and drag, it does not affect the chip at all. And if I'm over it, now it starts to move. And I can move it with the mouse. And as soon as I let go of the button, it stops moving. And then if I go in here and I change the drag to be click activated. So here's my chip. I click on it. And now it's set to active and it's ready to move. And I can move it about the screen. Click it again and it stops. And note that if you actually click and hold the button, it'll still move for you. But you do have to release the button and click it again in order to set it back down. So I've updated the checkerboard screen, added a black chip, so I have both those on the screen. My mouse drag movement is still click activated. So I can launch that, show how that works. So if I click on the red one, I can drag it and it will not move kind of at where the other chip is because it has collision. I can set it down and click on this one and it does the same thing. Now there is a bug in the code. So if I turn this off, just remove that and then run it. Now this is where you click and hold it to move it. And so you can see if I click up here and drag down, it'll pick it up and move the mouse or move the chip as well. And then if I drag it over this one, it swaps them. And so we'll fix that bug here. So first I renamed these to be more appropriate. They're the X and Y click offset. Now I've added an X update location and a Y update location. So in the handle collision method, so is over actor, it now uses the X update and Y locations, and we check to make sure that the button activation is not set. And so if it's no longer over the sprite, then we set active to false and we reset our X and Y update locations. In the update method, we set the X and Y update locations based on the screen input. We check to see if the mouse is over the actor. And if it's just been pressed, then we want to set active to be true, but we also want to set it to be button activated, that it either toggles on or off. And if it's not button activated, then we set it to true. Then we check to see if we're not button activated and we are active. That means it's just click to move. Then it is only active based on is the button being pressed currently. And then I've updated the if active, it now uses the X update location, Y update locations to set the locations. And if it's not active, then it just sets those to 0. Okay, and then we're going to test it with our button activated. And here it is. So we have our two mouse. So if I click up here and try dragging down, it doesn't trigger it. And then if I click on it, we've got it activated. Click again, it deactivates. And I click, I can hold, and then I have to release and then click to deactivate it. And then if I go over, it will pop to the other side like it did before. And so that works for both of them. And come back in here, and I can set the button activation off. Start this up again. So now if I click from up here and drag down, it doesn't trigger it. If I click and I let go, you can see it activates only while I have it clicked. And then if I come to hit this guy, and then now my mouse is no longer over that chip, and so it's no longer active. And the same here, and I can't re-pick it up. I have to click it again. Alrighty, and that is our mouse drag movement. And that's going to do it for this video. And the next video, I'll actually add in layers to our game screen and show you how that works with the mouse drag to change the layers. So if you like the video, give it a like and feel free to subscribe, and we'll see you in the next video.